Hello students, hope you are doing well. In this video, we'll look into the next topic of center of mass and collisions, and that is conservation of momentum and the collisions itself. Now, what does conservation of momentum say, or the principle of conservation of momentum say? Principle of conservation of momentum says total momentum of a system is conserved if there is no external force acting on the system. So if there is no net external force acting on the system, the total momentum of the system is conserved. And so that comes from Newton's second law. Now what does Newton's second law say? Newton's second law says F equal to dp by dt, rate of change in momentum equal to force. So if F net equal to 0, that means what? dp by dt equal to 0 or momentum equal to constant. So whenever we have situations where we talk about conservation of momentum, we check whether the forces involved are external or internal. If external forces are involved, then we cannot consider conservation of momentum. But if only internal forces are involved, then we can consider conservation of momentum. So when momentum is conserved, I can say total initial momentum. So total initial momentum will be equal to total final momentum. Total initial momentum is equal to total final momentum. Then let's look at collisions. Now what is a collision? A collision is an isolated event in which two or more bodies exert relatively strong force on each other for a relatively small interval of time. So what is a collision? So collision, in other words, can be defined as interaction between two bodies for a very short period of time. So if there is interaction between two bodies for a very short period of time, then we say it is collision. So again, so if you are talking about collision, what is happening in a collision? Now let's say one object and two objects are coming towards each other. Now they start interacting, they will deform, and they would either partially regain shape or totally regain shape. So this part is the process where the collision is taking place. Now, if it is totally regaining its collision, we call it as elastic collision, and if it is partially regaining its original shape and size, then we say it is inelastic collisions. Of course, we'll be discussing that in detail. Now let's look into elastic collision. A perfectly elastic collision is defined as one in which the total kinetic energy and momentum of the system is conserved. Momentum is anyhow conserved because the interaction between the particles is too small for the external forces to come into picture. So only internal forces are coming into picture, and hence the momentum is conserved. The kinetic energy, there is no loss of energy. If there is no loss of energy, why do we call it as elastic collision? Like we were discussing in the previous slide, two bodies come in contact, they undergo deformation in shape, and if they totally regain their shape, that is called elastic collision, right? The ability of a system to regain its shape completely is called elasticity. And in this process, what is happening? There is no loss of energy. So because there is no loss of energy, what is happening? The total kinetic energy before collision is equal to total kinetic energy after collision. But kinetic energy during collision will be less than initial or final kinetic energy. Now why does that happen? Because during collision, a part of its energy is converted into potential energy, which is reconverted into kinetic energy after collision. So in a perfectly elastic collision, kinetic energy before collision is equal to kinetic energy after collision. Now let's get expressions for velocity and so velocities of the particles after collision. Let's say we have two particles, particle of mass m1 having velocity v1 and particle of mass m2 having velocity v2. They collide. Initial velocity will take it as u1 and final initial velocities of both of them will take it as u1 and u2. Final velocities as v1 and v2. So after collision, their final velocity of the first particle is given by m1 minus m2 by m1 plus m2 into u1 plus 2m2 u2 by m1 plus m2. This is velocity of the first particle after collision. Now similarly, velocity of the second particle after collision is given by v2 equal to m2 minus m1 by m1 plus m2 into u2 plus 2m1 u1 by m1 plus m2. This is what, this is velocity of the second particle after collision, right? Now let's look at some special cases. If m1 equal to m2, what will happen? m1 equal to m2, then what will happen to v1? v1 would be equal to, this part becomes 0, it will become 2m by m plus m2m into u2. So this cancels. So I'll get v1 equal to u2 and u2 equal to v1. So that means what? Bodies exchange their velocities. So when the masses are same, so bodies exchange their velocities, right? The next thing, this is case 1. Now case 2, let's say we have m2 is very much greater than m1, right? And is at rest. That means you are throwing a ball towards a wall. The wall doesn't move, but then what will happen to velocity of the ball? So then in that case, v1 equal to m1 minus m2 by m1 plus m2 into u1, right? Now m1 is very much smaller compared to m2, so I can write v1 equal to minus m2 by m2 into u1. So what does it mean? v1 equal to minus u1. So the body will reflect with the same speed. So these are a couple of special cases that, if you remember, would be helpful for you in the exams. Then we have inelastic collision. So what is inelastic collision? A collision in which only momentum is conserved is known as inelastic collision. So the way we are discussing here, what is happening? The bodies do not completely regain their shape. So there is a loss of energy. So kinetic energy before collision is not equal to kinetic energy after collision. But we can still use m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Why we can use it? Because the momentum is conserved. So we need one more equation. We define a quantity called coefficient of restitution. That's a dimensionless quantity which is given by E equal to relative velocity of separation by relative velocity of approach. That means E is relative velocities of bodies after separation by relative velocities of bodies before separation, that is u2 minus u1. This is what is coefficient of restitution. So now we have two variables and two equations. So using these two equations, we can find the final velocities of the bodies after collision. Now you can just look at an example here. So here what is happening, the two bodies are colliding, and then what is happening is they are not actually regaining their shape. It's not shown. The next thing that we have to remember in inelastic collision is we can even find the loss in kinetic energy. So how do we find loss in kinetic energy? Delta Ke. Delta Ke is equal to, initial kinetic energy, I'll say initial kinetic energy minus final kinetic energy. Now sometimes they'll ask you fractional loss in kinetic energy. Now what does fractional loss means? It is loss in kinetic energy, that is initial minus final by initial kinetic energy. This is what is fractional loss. And sometimes they'll ask you percentage loss in kinetic energy. Percentage loss is fractional loss into 100. So initial kinetic energy minus final kinetic energy by initial kinetic energy into 100. This will give us percentage loss in the kinetic energy. So you need to be very careful while reading question what is asked and accordingly find it. Sometimes they'll ask you what is the kinetic energy left with one of the bodies. Sometimes it is asked what is the fractional loss. Sometimes they just ask what is the percentage loss, anything. Then we have something called perfectly inelastic collision. So what is a perfectly inelastic collision? A collision in which both the bodies stick together after collision are called perfectly inelastic collision. So in a perfectly inelastic collision, I can say m1 u1 plus m2 u2 equal to m1 plus m2 into v. Now v is the combined velocity. So v would be equal to how much? m1 u1 plus m2 u2 by m1 plus m2. So in case of perfectly inelastic collision, the loss of energy is maximum because there is no reconversion of potential energy into kinetic energy. And looking into coefficient of restitution, E equal to 1 implies it is perfectly elastic collision. E is less than 1, that is 0 and 1 implies it is inelastic collision. There is a loss of energy. And when E is equal to 0, it implies it is perfectly inelastic collision. There is no relative motion between the objects after collision. So perfectly inelastic collisions. So this is what are the basics of collisions. What all things we have seen, we have tried to define what is conservation of momentum, what are the conditions under which momentum is conserved. Then we define what is collision and the different types of collision, that is elastic, inelastic and perfectly inelastic collisions. Hope you could follow this. Thank you very much.